I'm going to take this opportunity to introduce you to what is an uncommon condition, and it's actually quite an intriguing and unusual condition called visual snow. Obviously, this slide tells you exactly what I'm going to do. I'm going to talk about what we do know and essentially what we don't know, and what you'll discover is that's a great deal. Because I'm assuming that many of you have actually never even heard of visual snow. As I said, it is a rare condition, although probably not as rare as we think it is or has previously been thought. Here we're talking about a persistent positive visual phenomenon. So as Jay Sherry said, it resembles a veil of flickering dots. And these dots, if you like, are distributed right the way across the visual system, right the way across the visual field. So you see it from top to bottom, left to right, and it doesn't change in its intensity from left to right either. So whole of visual field experience. And again, as Jay Sherry pointed out, it's actually been described as quite similar to the static of a poorly tuned analogue television. And looking at my audience, I'm thinking probably not many of you know what that actually looks like. You'll have to take my word for that. And what's significant is this field of flickering dots is actually present irrespective of whether the eyes are open or closed. So it's a 24/7 experience. And this graphic that I've put up here really doesn't do it justice. So you get a sense of this veil of dots, but picture these moving continuously. In terms of the description of visual snow, we tend to have a bit of variability. Typically they're black and white, but there are reports of colour. A significant number of people see these dots as shimmering dots or veil of flickering dots in colour, but they can also be sort of white flashing dots, and even reports of transparent dots. So we've got quite a bit of variability in terms of the way it's perceived. It does tend to vary in terms of the lighting. So in bright lights, the dots are less obvious. And in terms of backgrounds too, so the dots are more obvious if we have a plain background compared to a background which is textured or is busy, so to speak. And also in terms of the impact that visual snow has on the individual, that's hugely variable. So we have reports where there's a mild disturbance, so it's mildly intrusive. So some people will see the shimmering dots but get on with their lives. But that goes right through the full spectrum of disorders, right the way to traumatically impacting a person's life and reducing quality of life. And that'll make sense when I start to show you some of the associated symptoms. So the more symptoms, the more intense the visual snow is, the poorer the quality of life. We also have reports of people experiencing visual snow for all of their lives. So that indicates that they're either born with the disorder or it develops in very early childhood. But more often than not, what we see is a sudden onset of symptoms. Quite often follows a headache, or somebody will wake up the next morning after a previously unremarkable night with these symptoms, as I said, spread right the way across the visual field. And typically what we find is that there isn't a set of precedents, so we don't know what triggers the onset of visual snow, and that speaks to how little we know about the disorder. So we know the earliest cases of visual snow were reported back in 1995, so it's actually really quite recent, and these were accidental findings. So a group of scientists were looking at some case studies, and these were migraineurs who experienced persistent visual symptoms. So here we're really looking at aura. But 3 of the cases that this group reported actually had what we now recognise as visual snow. And certainly over the last 20 odd years or so, we have an increasing number of cases that appear in the literature, literally hundreds of them. Having said that, it's only recently that visual snow has been recognised as a neurological condition. So previously, and unfortunately still today, there's a great deal of misdiagnosis of this condition, or not a great deal of recognition that this is actually a neurological symptom. So what's happened historically is if it was diagnosed as being anything at all, it was misdiagnosed as migraine aura. And this is despite the fact that migraine meds don't work, including preventative medications, antidepressants, pain meds. Nothing at all alters this experience of visual snow at all. Anecdotal cases of some success with lamotrigine, which is an anticonvulsant that it tends to have some effect or impact on aura, but their reports are certainly very, very inconsistent. So we're looking at a condition where we have absolutely no definitive treatments in the first place. What's more disturbing is that patients are usually told there's absolutely nothing wrong with them, that they're completely normal. Or more disturbingly, they're told that it's psychogenic, so they're told that it's a psychological problem, even told that they're malingering, and by that I mean they're faking the symptoms, attention seeking. The big issue here is that when these individuals turn up at a GP, optometrist, ophthalmologist, they run all of the tests, so all of the electrophysiological tests, all the visual acuity tests, and even MRIs, and all of these come back completely normal. Now, I am talking about clinical tests as opposed to experimental tests, but of course they walk away with no diagnosis. They're told to go away, there's nothing wrong with them, but of course 24/7 is sensory experience that they're living with. And you can imagine the distress of an individual who sees visual snow 24/7 and is told there's absolutely nothing wrong with them. So you see a whole subset of individuals that go doctor shopping and looking for answers. All these sorts of useless tests that I've demonstrated, none of them actually show any form of change. So what turned this around about sort of half a dozen years ago was a UK group led by Dr. Peter Goadsby. He's actually an Australian neurologist, but he and his team performed a survey of hundreds and hundreds of people who reported visual snow. So these were chart reviews, internet surveys, telephone interviews. And what they did is build up a picture of what visual snow looks like. So they looked at associated symptoms, the personal experiences of each of these individuals, as well as the sort of events that preceded the onset, usually the sudden onset of visual snow. And what they concluded was that visual snow was actually very distinct from migraine. And this is despite the fact that about half of patients actually also suffer from migraine, hence the confusion and the misdiagnosis. So we have visual symptoms that look like aura. Quite often we've got migraine, but here we've got a set of criteria that determines, no, we've got something that's completely different to migraine. And what he also found was it was a common cluster of visual symptoms that co-occurred alongside visual snow. So the conclusion that this group reached, and they were very influential, was that visual snow is clinically distinct in terms of an entity that should be defined as its own syndrome. And certainly we now recognise that this is a neurological entity, and we now have a syndrome known as visual snow syndrome. So this is the classification. So in the International Classification of Headache Disorders, it's now registered or listed under the complications of migraine. So here we're talking about those continuous dots, entire visual field, and persistent for more than 3 months. As I told you before, this is a 27 phenomenon. It doesn't go away, it doesn't get better, tends not to progress, but it is persistent. And then a host of additional visual symptoms, palinopsia, entoptic phenomena, photophobia and nyctalopia, and I'm going to show you what they look like right now. So we have a formal diagnosis. It's a thing, which is fabulous for patients. It doesn't help them because we don't know what it is, but at least we can make a formal diagnosis and send a patient away with the assurity that we're working on a cure. So this little image you'll recognise as what I've been talking about in terms of visual snow. But here I'm showing you palinopsia. So we're looking at after images and trailing of moving objects. Now this is quite different to the retinal after images that you see when you're looking at high contrast stimuli. Typically you see the complementary colour as the after image. What you've got here is a series of trailing images that are identical to the original image, so it's quite different. And have a look at the prevalence rates here, so it's no wonder this was part of the diagnosis. And here we're looking at enhanced entoptic phenomenon, easy for me to say. So we're looking at floaters, and these will be phenomena that you're actually really familiar with, but we're talking about excessive numbers of floaters. So these are shooting across across vision all of the time. Blue field, entoptic phenomenon. Typically when you look at a sort of a bright field and the sky is as typical of that, you'll see sort of squishy dots and wiggles moving across the sky. You and I will see that. If you look long and hard enough to blank all or up at the sky, you'll see these floaters and these ectoptic phenomena. But in visual snow, they're present 24/7 and they really intrude in terms of the vision. Self-lighting, this is talking about when you close your eyes. You don't see nothing when you close your eyes. You can actually see swirls and clouds of colour quite frequently, as well as spontaneous photopsia, so flashes of light. So if you think about it, all of these phenomena you or I see, or at least recognise, and we've noticed it from time to time, but these people with visual snow see it all of the time. And nyctalopia, so poor night vision. Anyway, you put that all together and that's the mess. So this is likely what somebody with visual snow sees. And this is just the tip of the iceberg because nothing's moving here. With somebody with visual snow, you've got movement of the trailing after images, you've got movement of the snow and movement of the entoptic phenomena. So quite disturbing. So you can imagine being told that nothing is wrong with you when this is what your whole world looks like, 24/7, eyes open and eyes closed. You probably find it, since I've just told you that visual snow is not associated or is not a migraine variant, but it appears in the International Classification of Headache Disorders. But having said that, the ICHD actually acknowledges that it's not likely to be part of the migraine spectrum, but epidemiologically it is associated or appears to be associated for several reasons with migraine with aura. So we know with both visual snow and migraine, we see increased palinopsia and visual sensitivity. And those people who experience both visual snow and migraine actually have more incidences of palinopsia, photopsia, etc., than those that don't have corresponding migraine. The idea is that we may be looking at similar underlying pathophysiology, and that's a sort of starting point for the research we're conducting. And the reason they chose to conclude this in this particular classification is firstly just to raise awareness and make it known to clinicians in particular, this is indeed a neurological condition. And that's really important. So saving on misdiagnosis, saving on these sort of endless tests to try and find out what's going on and reassuring patients that this is indeed a neurological entity. What I also want to talk very briefly about is a range of non-visual symptoms. So I've talked about visual snow syndrome, and that speaks specifically to the range of visual symptoms. But what accompanies visual snow typically are a range of non-visual symptoms, and I've given you some indication of where I can of how often they do co-occur. I've already said migraine's quite common, so for around half of patients that's typically the case. And tinnitus is quite interesting too, as high as 62%. If you think about what tinnitus is, it's sort of a auditory version of visual snow. So the commonalities there are quite interesting. Paresthesias are quite common. So pins and needles, strain sensations in the extremities are not uncommon. Anxiety, poor concentration. And these symptoms, depersonalisation and derealisation, I've labelled them psychiatric symptoms, are extremely common. I don't have figures on these. But the girls that are testing these patients in my lab tell me just about every single patient they test says that these are the symptoms that they do suffer. So they're not just visual, and they can be any sort of sensory disturbance. So we've accepted that visual snow syndrome, and I'll stick to the syndrome at the moment, is a neurological condition. They're all visual symptoms, so they have to be somewhere in the visual system. They have to be controlled by this broadly distributed and widely diffuse system. If you think about how much of the brain this constitutes, we're looking at over half of the brain that's involved in processing vision and control of eye movements. So from the eye right back through the optic nerves, back to the visual cortex, but also large swathes of the occipital cortex, the parietal lobe, temporal lobe, and right the way through to frontal cortex, all involved in processing vision in some way or another. So where do you start? Well, we start with knowing what visual snow is not. And we know where it's not. It's not in the eye. As I said to you, it's present with the eye open or eye closed. We know it's not in the optic nerve. At that point, we're still seeing separation of left and right. As I said to you, visual snow appears uniformly over the entire visual field. And that's the case also with striate cortex or visual cortex, those early processing regions. There's no difference in left and right and up and down. So we know it's not located within visual cortex, and that's a good start. What it means, it has to be higher up, I guess, in the regions of the brain that process a fully merged image of the field of view. So I'm talking about the visual association cortices, parietal spatial maps, as well as prefrontal cortex. So all of those regions that allow us to make sense of what it is that we're seeing, so they're contextualising and interpreting the visual information that's fed back to visual cortex. We're also interested in the thalamus, a group of nuclei that sort of integrates and modulates information to and from cortex. And it does this through a number of recurrent thalamocortical loops that gradually build up a meaningful picture of what it is that we're seeing, and ultimately allows us to determine what reaches awareness or consciousness and what doesn't. Looking at the time. So I'm particularly interested in the thalamic reticular nucleus. This is it's a little sheath of GABAergic neurons that actually wraps around thalamic nuclei, and it communicates only with the thalamus, but it does receive information to and from cortex as well. So it effectively acts as a gatekeeper around the thalamus and determines what it lets through to cortex. So this regulatory role is quite important. And what I like about it is that it is not just involved in vision, but involved in all of the senses. So if you think back to those other symptoms that I showed you, those other sensory symptoms, it kind of makes sense that something in the middle of the cortex in the thalamic region would have some sort of influence on those symptoms as well. So I'm going to whip through these in the interest of time. There's only a handful of papers that have ever been written on visual snow. We're one of the few groups in the world that have started studying this. This is one of the earliest papers by Peter Goadsby, who I talked about a moment ago. These are results from a PET study. All of these studies, and there's only a handful of them, use very small numbers of patients, so I want you to bear that in mind. But what they found was increased metabolic activity in the lingual gyrus and the cerebellum. And to cut a long story short, what they proposed was that these are microstructural changes to higher order visual processing regions, which is consistent with what I was saying in terms of where this must be. What it doesn't answer is what's driving those changes. So we have increased metabolic activity, but what is actually driving those changes is really uncertain. So a second imaging paper by this group looked at cerebral blood flow using fMRI, and listed a whole heap of regions here where they found increased blood flow, cerebellum, cuneus, insula, etc. So these regions are not only involved in visual processing, but are also involved in this idea of consciousness or awareness, if you like, as well as controlling eye movements. And they measured the blood flow both at baseline, so when the patients were doing nothing, as well as when they were looking at what is effectively visual snow stimuli. So while the patients were in the scanner, they actually fed back their visual snow to them visually. They didn't find any changes, but the idea behind that is we have a great deal of anecdotal evidence that doing that actually attenuates or diminishes the experience of visual snow if you do it for long enough. So some patients feel complete relief. The symptoms disappear after watching visual snow, back into the system after a little while. It doesn't cure it, doesn't go away, it comes back. But you can imagine if you have a 24/7 experience and you get even 5 minutes relief from watching these sorts of stimuli. And it's quite similar to what you find in tinnitus. That's one of the treatments with tinnitus also. So a clinician will find or identify that frequency that is the tinnitus in an individual and feed that frequency back to them. And again, they get temporary relief from their symptoms. Stress temporary, it's not a cure, and it's highly controversial. What they determined with this particular study, that it was a marker of resting state hyperactivity, consistent with their PET study. What's emerging through each of these bits of research is this idea of cortical hyperexcitability, which is something that's quite consistent with migraine, although we do see some sorts of differences. But we're starting with this idea of hyperexcitability, or cortical hyperexcitability. This is a little bit less compelling. Visual evoked potentials rather. This is a clinical examination, and it's fairly nondescript in terms of where the deficit is. So again, a small group of patients, and they found a number of electrophysiological changes of an EEG correlate, if you like, for the hypermetabolism in visual association cortex. Again, we're looking at this idea of changes in the association cortex. What doesn't excite me about this is I was reading a brand new article this morning which completely contradicts this, and you see a lot of anecdotal reports, we're done, okay, that contradict this particular finding. And I'm going to whiz through, I'm going to skip through these particular findings. Hopefully this will be recorded somewhere and you'll be able to have a quick look at it. But we come to the end of the published studies, and that's it. I wanted to show you what we were doing in our lab, but we have mountains of data that we haven't completely analysed, and I don't want to mislead you. But we're looking at changes within the oculomotor system, and particularly changes to attentional processes. So these are the same sorts of regions that are implicated in vision, but also implicated in the control of saccadic eye movements. So what we've been doing, we have about 50 data sets, about 300 hours of recording, which we're trawling through. So as I said, I don't want to misrepresent our results by calling it early. But we can see attentional changes. We can measure what the changes throughout the system, the visual system, by using oculomotor measures. Doesn't seem to be completely consistent with what we know about some of the other change or associated changes in visual snow, particularly the ones that originate in the eye, so floaters and light flashes, etc. But if you think of this in terms of being unable to filter what our brain normally filters out, then that kind of makes sense too. And that could be at the level of the thalamus. So information is not being processed by the cortex because it's filtered normally in you or I. We stare at a wall long enough, we're going to see floaters, for example, but our brain allows us to filter that out. So collectively, the research, including the work that we've been doing, which is going to be fascinating, you'll have to bear with me, is this idea that there's a sort of a failure to stop the transmission of noise. So whether that noise is the visual snow itself, or those entoptic phenomena, the floaters, etc., that's irrelevant, or possibly diffuse changes within the cortical regions that process visual information. So what that indicates is that we don't know very much at this point in time, very few studies. And we have a large group now, and I've got a handful of students all working happily on visual snow projects at the moment. So we have monster data sets for the oculomotor data, working on setting up our imaging protocols, introducing EEG, looking at genetics, and hopefully we'll combine the whole lot of those at some point and come up with some sort of causation model. That's for the future. It's being helped along by this. We had a very generous donation by the Visual Snow Initiative. Now, it's a US initiative. It's a not-for-profit foundation. Their objective is to raise awareness, which is very important, of course, as well as raise money for funding. Said we look very happy, you can tell, receiving our giant novelty check. And a nod to our crew here, some of them are in the audience. I'll leave it there because I've run out of time. Thank you.